Okay, we're continuing on with exponents. So we were 22, now we're 25. So this is very similar to the last problem we did. We got 4/5 raised to the -2 power. So again, there's two ways of doing this. You can rewrite this as 4 to the -2 divided by 5 to the -2. Then you can move this one to the denominator, change the sign of the exponent. You can move this one to the numerator, change the sign of the exponent. Then you can carry out your calculations. 5 squared is 25, 4 squared is 16, and that is your answer. You can't simplify that any further. The other option is to take the reciprocal of the original thing and then change the sign. And you get the same answer. Okay, 28, 8 to the 0 power. Any number raised to the 0 power. Is 1. Now, except 0 to the 0 power, or infinity to the 0 power. Really, infinity is not a number. Even x to the 0 power is 1. So even a variable, you don't even have to know what the number is. Okay, 31. -4 to the 0 power. Well, we just said that any number raised to the 0 power is 1. Positive or negative. Okay, we're going to skip a few here. Not sure why, but we are. $39. So what we've been dealing with up to this point is actual numbers, but if you have variables, you use the same laws as long as the base of the expressions are the same. So if you have, in this case, x to the 12th times x to the 4th, because we have the same base, even though it's a variable, you can rewrite that in simplified form. Because we're multiplying the numbers together with the same base, you add the exponents together. And so that's going to be x to the 16th power. Now 42 actually has a number. Again, we have the same base. So the rule says that if you have the quotient of two numbers which are exponential numbers with the same base, it's going to have the same base in the answer. And you take the exponent in the numerator and you subtract the exponent that's in the denominator. And so we get 3 to the -1 power, but we can't evaluate that because it's negative, so we rewrite this as just 3 to the -1 divided by 1, so that now there's a denominator. So then you can move this to the denominator, and then you can evaluate that, which is 3 to the 1st power is just 3. So this thing simplifies down to 1/3. Yep. Okay, let's go 45. I think that's the next one. 45. 9 to the -1 divided by 9 to the 1st power. So there's a couple of ways you can do this, and you get the same answer. One would be to just use the quotient rule, which would say you have 9 to the -1 power, and you subtract the exponent that's in the denominator. They're both to the same base, so everything's great. And so you get 9 to the -2 power. But we never finish. We don't just stop here with the negative exponent. So again, we could make that into a rational number by dividing by 1, and therefore we can then move the 9 to the negative 2 power to the denominator by changing the sign, and then you can actually carry out the calculation. So 9 squared is 9 times 9, which is 81. So you get that. Now, how else might you do this? I could move this to the numerator and change the sign, and then I use the product rule where I would add these two together, and then I do the same thing as this. Or the other option would be to take this 9 to the minus 1 power and move that to the denominator and make it positive. Then I would have 1 over 9 times 9, which would be 1 over 81. Sorry about that. Just knew I had to sneeze. Okay, 48. I have p to the 5th times p to the minus 6th. Again, I have two exponential expressions with the same base, which in this case is a variable. So when you have a product, you add the exponents together. So one exponent is negative 5. You add, well, actually it's the other way around. Sorry, I got ahead of myself here. So you have 5. You add negative 6. That's the same as subtracting 6. So I get p to the minus 1. But we never stop with a negative exponent. We always simplify it. So again, I create a rational number. I then move this to the denominator. P to the first power is just p. So my final answer is 1 over p. Okay, let's do one more for this group, 51. So we have a to the minus 3 times a to the 2 times a to the minus 4. So if you have more than 2 terms in a product, it doesn't really matter. You still apply the same rules. You're going to add the exponents because you're multiplying together. So that's going to be equal to a to the negative 3, I'm going to put this in a parenthesis, plus 2 minus 4. So I get a to the, well, negative 3 plus 2 is negative 1, minus 4 is negative 5. So I get that, but I change that and move the negative exponent to the denominator, make it positive, and that's your answer. 1 over a to the 5th power. Okay, so we'll stop for that group.